Okay, so in this lesson we will address the essential question: what formulas can you use to find the area of a triangle if you know the length of two sides and the measure of an included angle? Well, let's take a look at an arbitrary triangle here. Let's say we wanted to find the area of this triangle, but you have to remember first what area actually tells you. The area of a triangle is the space that the inside of the triangle takes up. Okay? Contrasting that with the perimeter is the distance around the entire triangle. Okay? Perimeter is the distance around the entire triangle. So if I start at this point, walk in this direction along the edge of the triangle, measure that, do the same with this side and this side. If I add all those distances up, I will have the perimeter. That's very different from the area. The area measures how much space is on the inside of the triangle, so the bigger the triangle, the bigger the area. Well, you remember the formula that we use to find the area of a triangle is this formula here, 1/2 times the base times the height. But which do we call the base, which do we call the height? Well, the choice of base is arbitrary. I could easily choose this as the base, this as the base, this as the base. So let's say, for example, I choose this side here as the base. Then I'm forced to choose this distance here as the height. Okay, this distance here is the height of the triangle, in other words, how tall this triangle is. Okay? Or I could just as easily choose this as the base, and then I'm forced to choose this as the height. Either choice will give you the same exact number for the area. Okay. So let's say we have an arbitrary triangle given here. Alright, so let's take a look at this triangle. I'm going to call this vertex A, this vertex B, this vertex C. And by convention, we call the side of the triangle that's opposite of angle A, we call that little a. We call the side that's opposite angle C, little c. We call the side of the triangle that's opposite angle B, little b. Like this. So if you see a capital letter, you'll always know we're referring to an angle, whereas if we refer to a lowercase letter, you know we're referring to the side opposite that angle. Okay? So suppose we have an arbitrary triangle ABC with side lengths little a, little b, little c as shown, and let's say that this triangle has a height h. Okay? Notice we create two right triangles here. Triangle big A, little a, big C, and triangle big A, little a, big B. So I have two right triangles here because this line segment here basically divides the triangle into two right triangles, because this right here represents how tall the triangle is. Okay? So looking at this angle C, notice that since we have a right triangle, I know that I can use the trig ratios to establish a relationship between the sides of this right triangle. Or in other words, I know that the sine of angle C is the opposite leg of the triangle, of this right triangle here, the opposite leg divided by the hypotenuse, which we denote little b. Now if I solve this equation for h, notice I get h equals b times the sine of C. You'll see why this is useful in a second. Okay? Well, we already know that the area of this entire triangle ABC is going to be 1/2 times the base times the height. Well, we're choosing the base to be little a. If we're choosing the base to be little a, then we're forced to call the height of this triangle little h here. Okay, so this is the height of the triangle. So I know that the area of this triangle is given by the formula area equals 1/2 times the base, little a, times the height of the triangle, little h. But wait a minute, I've already expressed little h in terms of the side B and the angle C. So I just substitute this expression for h into this equation for the area of the triangle, and I get that the area of the triangle is 1/2 times the side length A times the side length B times the sine value of angle C. So what this does is it gives us a formula to use for any triangle. Okay? Now, suppose we have a triangle, an arbitrary triangle ABC. I know that the area of the triangle from our previous work is going to be 1/2 times little a times little b times the sine of C. But notice here that I can easily choose this point here to be A, this point here to be B, and this point here to be C. What this formula basically tells us is if you want to find the area of any triangle at all, you take two sides, take half of the product of those two sides, and you multiply by the sine of the angle that's included by those two sides. So notice that I have side length little a here and side length little b here, right? Notice that the included angle, or the angle between those two sides, is exactly C. So in order to use this formula for area, you need to make sure that you're using the included angle C. Okay? For example, I could not use this area formula if I knew only the side length AB, but the non-included angle A. I couldn't take the area would be equal to 1/2 times A times B times the sine of angle A. The angle has to be the included angle, or the angle between the two side lengths. Remember to come to class prepared to answer these questions for the notes quiz. Okay, so here's an example of how you use this formula. Suppose I wanted to find the area of this triangle. Well, I don't know the height of this triangle, but I do know a couple side lengths and the included angle. So according to our previous work, the area of this triangle is going to be 1/2 times this length times times the sine of the included angle 114 degrees. Substituting those values into our formula, I get this, that the area is 1/2 times 13 times 11 times the sine of 114 degrees, which gives me that the area is approximately 65.3 centimeters squared after putting this into my calculator, sine of 114 degrees. Okay, so for this reflect question, suppose you double each of the given side lengths in the triangle, but you keep the measure of the included angle the same. How does the area change, and explain? Okay, so the essential question that we answered with this lesson is, what formula can you use to find the area of a triangle if you know the length of the two sides and the measure of an included angle, the key thing being that the angle is included? Well, you just use the formula that the area is equal to 1/2 times those two side lengths times the sine of the included angle.